Hey everybody, it's Mr. N again. All right, so this is Law of Sines and Cosine, more practice in case you didn't get it the first time. So let's take a look at this. On the first one, it says solve each triangle. Now remember, whenever we said the instructions say solve the triangle, that means we need all the angles and all the sides. So for this first one, I'm going to call this little side A opposite angle B. I'll call this little b opposite angle C. I'll call that side C. So I take a look at this. It's not a right triangle. I can't use any of the right triangle things I know, such as SOHCAHTOA, Pythagorean theorem, 60, 30, 90. So what I need to do is now I go on to the law of sines. So the law of sines said sine of A over little a, so sine angle A, is equivalent to the sine of angle B over little b, sine of angle C over little c. So sine of angle A over side A, side angle B over side B, side of angle C, sine of angle C over side C, and we'll set up the ratios. So here's angle A. I don't know what that is. I'll just write in sine A. I do know what little a is. That's 25. Sine of B. Well, that's sine of 62 over little b, which is 28. And then sine of C over little c, which I don't know either. So I don't know that side. So now look, here's what I'm trying to tell you from our notes from before. If I use these two, remember I can use any two to solve for a missing side or angle. If I choose to use these two, notice right here I have two variables. I won't be able to do it. Same thing if I chose the first and the third. Two variables. Actually, there's three at this point. I won't be able to do it. But if I choose the first two in my ratio, then I can solve for angle A. So let's go ahead and do that. So over here, I'm going to say the sine of A over 25 equals the sine of 62 over 28. At this point, we're going to cross multiply. So I can say 28 times the sine of A equals 25 times the sine of 62. I want to get rid of the 28, so divide each side by 28. Now, many of you have realized with these ratios, all you have to do is multiply this to this side. So sine of A equals 25 sine 62 over 28. You didn't have to multiply this back over here. Just move that over to there, and this is what you have. So let's solve this, and we're going to need to put it in our calculators. So in our calculators, we have to find what the sine of 62 is times 25, and then divide that answer by 28. So I've put this in my calculator, and the sine of angle A is equal to 0.7883. I'm going to go out to one more place. I told you guys to go out to at least 4 places, and it makes a difference on how it rounds the angle. So now to solve this, A will be the inverse sine of that answer. So on my calculator, I'll take the inverse sine of it, of 0.77834, and I will get A as being 52.0312 degrees. So now, I've got angle A right here. So this part I've solved for. So we can move on, and I can solve for angle C really fast now, because 180, oops, let's go back to this color, 180 minus 62 minus 52.0312 is what angle C will be. So we can figure this out on our calculators, and we will get angle C as being 65.9688 degrees. So now I've got the next thing. I've got angle C here. All right, so now I need to move on and find out what angle B, or I'm sorry, what side C would be. So I have side A, I have side B, I have angle C, I have angle A, I have angle B. The only thing left is to find side C. So I'm going to go ahead and use these two again. I'll go ahead and use these two because I know them. So I'll say the sine. I know the other ones as well, but it doesn't matter. So sine of 62. I don't know why it keeps doing that on me. Sine of 62 over 28 equals the sine, and I know what angle C is, at 65.9688 over little c. Again, to cross multiply and solve, c times the sine of 62 equals 28 times the sine of 65.9688. C will be this divided by the sine of 62. So let's work that out. Again, all I did was divide each side by sine of 62 to isolate C. Okay, so on our calculators, we could put this in, and I will get an answer of 28.9633 for little c. And I've gone through and solved that whole triangle. So now for number 2, let's take a look at what we have. And it says A is 64 degrees, B is 41 degrees. We don't know angle C, we don't know little a, and we don't know little b. Well, we could solve for angle C right away, because angle C is going to be 180 minus the 41 minus the 64. So angle C is going to end up being 75 degrees. Okay, so now I have angle C, and it's not a right triangle. I can't solve for A using any right triangle stuff because it's not a right triangle, so we're going to have to go to the law of sines. So I set this up. Sine of A, that's 64 over little a. Sine of B, oops, let's just go ahead and put that in, and that's 41 degrees over little b. And sine of C, which is 75 over 28. So again, we take a look at this. Can I use these first two? No, I've got two variables there. Can I use the first and the third? Yes, I can, and that would solve for A. Can I use the second and the third? Yes, I can. That would solve for B. So let's go ahead and start by using the first and the third. So we have the sine of 64 over little a equals the sine of 75 over 28. Cross multiply, and I'll have you do that and check with your cross multiplication. You'll end up with 28 sine 64 over sine 75 is what A should be. Pause and take a look at how I did that if you need to. Okay, so I multiplied this here, I multiplied that there, then I divided by the sine of 75. One other hint, if it bothers you seeing these as sine 64, sine 75, go ahead and change these to decimals at this point. In other words, I'm saying you could change the sine of 64 to be the 0.8988 over A, and then you could take the sine of 75, which would give you 0.9659 over 28, and solve it that way as that ratio. It doesn't matter. So in the end, you'll get 28 sine 64, and then you're going to divide that answer by the sine of 75, and you'll get the value for A as being 26.054. Okay, now we can do the same thing for B. We could say the sine of 41 over little b equals the sine of 75 over 28. Cross multiply, so you'll end up with 28 times the sine of 41, and then b times the sine of 75, and you'll have to divide sine of 75 on each side. So there's b. Just like I said before, if that bothers you that I skipped a few steps there, cross multiply here, cross multiply there, divide it, pause the video to make sure you get this. You can also at this point change these, take the sine of 41, put it as a decimal, take the sine of 75, put it as a decimal. So I like to just do it in one step like that. So finishing this problem off, we have b equals, and then we said it's going to be 28 times the sine of 41, and I'm doing it on my calculator right now. Divide that by the sine of 75, and I will end up with 19.0176 is what B is. All right, let's move on to number 3. I'm going to slide this up. And then we have the same situation here. We have to solve this triangle. Here's angle A, and we don't know what, let's go ahead and change this. I'm going to use that color. And we don't know what angle A is, but we know inside A would be 20. Angle B is 93, but we don't know what little b is. We don't know angle C, but we know that angle side C is 14. So it's not a right triangle. Can't use any of the right triangle stuff. So I move on to the law of sines. So in this case, I will put the sine of A over 20 equals the sine of B over little b equals the sine of C over 14. Now, I take a look at the situation that I have here. And this is angle A. If I use the first two, I have two variables. If I use the second and the third, I've got two variables. If I use the first and the third, guess what? I still have two variables. So I cannot use the law of sines here because no matter what ratio I set up, it won't work. So I have to move on to the law of cosines. So at this point, I will type in or remind you what the law of cosines is. And it said a squared equals b squared plus c squared minus 2bc cosine A. Now, I didn't have to use angle A. In this case, I know what angle B is. I just need two sides that are included. So I need an angle and two included sides. So over here, if I use this version of it, remember it starts with A, ends with A. If I use this version of it, it won't work. So I want to just rewrite it so that you can see a version that will work. So over here, I'll just say b squared equals a squared plus c squared minus 2ac cosine b. Let's take a look at this. I know side A, I know side C. I could put all my values in here. So this is the one I want to use. So b squared will be a squared, which is 20 squared, that's little a, plus c squared, which is 14 squared, minus 2 times 20 times 14 times the cosine and angle B is 93. Remember, all of these are attached. Order of operations. This is all multiplication in here. So b squared equals 20 squared, which is 400, plus your 14 squared, which comes out to be 196, minus 2 times 20 times 14, so 2 times 20 times 14 times the cosine of 93. So I'm going to multiply all that together, and I will end up with negative 29.308. So at this point, I can clean this up a little bit. I'll get 400 plus the 196 plus, because negative, 29.3081 gives me 625.3081. Take the square root of that answer, and I will end up with B as being 25.0061. All right, so now at this point, I can take this and I can use it in the law of sines. I don't want to use the law of cosines again because the law of cosines is a lot of work compared to the law of sines. So I know the answer for B. I know this value. So I can go ahead and put it right up in here, and then I can use it to solve either this ratio or this ratio. So let's just go ahead and use the first one. So we'll say the sine of A over 20 equals the sine of 93, and now I know what little b is. That's 25.0061. Cross multiply, you'll end up with the sine of A equals 20 times the sine of 93, all divided by 25.0061. So working all this out, 20 sine 93, divide that by 25.0061. I'll end up with the sine of A as being 0.79871. A will be the inverse sine of this answer. So inverse sine of that answer that I got, 0.79871, and I'll get 53.007 degrees. So now I can go through and I can solve for angle C. So 180 minus 93 minus 53.007 is what angle C is going to be. So angle C will end up being 180 minus 93 minus the 53.007, and I will end up with 33.993 degrees. All right, so moving on to number 4. Let's take a look at what we have. I'm going to slide this over just a bit like that. And it says a triangle with A equals 4, B equals 8, and C equals 10. It's referring to the sides because those are all lower case there. So let's go ahead and draw it out just so you could see it. We have this triangle. If this is angle A, then side A is 4. If this is angle B, then side B is 8. And if that's angle C, then side C is 10. So this is obviously not a right triangle. I can set this up and to try to see if it's a right triangle. A squared plus B squared C squared, it won't work out. So we move on to the law of sines because I can't use SOHCAHTOA. So we have the sine of A, we don't know that, over 4 equals the sine of angle B, which we don't know, over 8, equals the sine of C over 10. All right, so now I take a look at this and I say, all right, if I use these two, oh, I've got two variables. If I use the first and the third, again, I've got two variables. If I use the second and the third, I've got two variables. So the law of sines doesn't work. What you should always recognize too is if you have three sides and none of the angles, law of sines won't work because the law of sines requires an angle. So we're going to move on to the law of cosines. So we move on to the law of cosines, and let's go ahead and just set it up as a squared equals b squared plus c squared minus 2bc cosine A. Again, I start with A, I end with A. These two would be in the middle. So I plug this in, and I'll get A, which is 4 squared, equals b squared, so that's 8 squared, plus c squared, and that's 10 squared, minus 2 times 8 times 10 times the cosine, and I don't know angle A. So it turns out that I'm going to need to solve for this angle A right here. So let's go ahead and see what we can do. On this, we'll get 16 equals 64 plus 100 minus, remember, all this is multiplication, so it's all attached. So 2 times 8 is 16 times 10 is 160 times the cosine of A. So at this point, just be careful. You could say 116 equals 164 minus 160 cosine A, but you cannot combine these right now because the 160 is being multiplied by the cosine of A. So what you can do, and what you want to do, is you're going to say 16 minus the 164. So we're going to subtract 164 from each side. So 16 minus the 164 will give you negative 148 equals negative 160 cosine A. All right, so at this point, we're going to divide, because this is multiplying by cosine of A. I will divide by negative 160 on each side, and I will get 0.925 equals cosine A. Well, how do I solve for A? I need to use the inverse cosine. So the inverse cosine of 0.925 is my answer. So let's go ahead and put that in our calculators. The inverse cosine of 0.925 comes out to be 22.3316 degrees is what angle A is. So now that I have angle A, I can go ahead and I don't want to use the law of cosines again. Let's put it back into the law of sines. So I know that the sine of A, so it's the sine of 22.3316 over 4 equals the sine of B over 8. Cross multiply. You'll get 8 times the sine of 22.3316 over 4 equals the sine of B. So we can work this out on our calculators. 8 times the sine of 22.3316. Divide that by 4, and I will get 0.7599 equals the sine of B. So to solve for B, I would have to take the inverse sine of 0.7599, that answer. So the inverse sine of that, and I end up with, putting this in my calculator, 49.4583 degrees is what B is. Now I can go ahead and solve for side C. So for angle C, you're just going to say 180 minus what angle A is minus what angle B is. And it's these two values right here. And angle C will end up being 180 minus the 49.4583 minus the 22.3316, and I'll get 108.2101 degrees. So now I've solved for all three angles. All right, moving on. Look at number 5. For number 5, it says, find the area of the triangle. So we talked about how to solve for the area of a triangle besides just saying the area equals 1/2 times the base times the height. We came up with a formula. We said the area is going to be 1/2 times, and we're going to use an angle with 2 included sides. But if you take a look at this, we've got an issue. We've got this angle, but we don't know this side. We've got this angle, we don't know that side. So then you could say, okay, well, what if I wanted to go back to the basics? What if I wanted to say, okay, well, if I did this and drop this down and call this h, then I could say the tangent of 29 is the opposite h over the adjacent 16. Well, that's wrong because 16 is only this length. It's not the length that's going all the way across from R to there. So you can't do that. So that, going back to those basics, it won't work. So what you do need to do here, and let me erase a bunch of this stuff so that it's not in our way, you are going to end up using the law of sines to solve for this missing side right here. Okay, so let's go ahead and do that. So let's set that up. We're going to say the sine of 29 over this. I'll just call this x, and I'll call this piece y. So the sine of 29 over x equals, I could say the sine of 109 over y, and here I could say this angle would be the 180 minus the 108 minus the 29. So this angle in here would be 42 degrees. 109 from 180, then subtract another. Yes, that's correct. It would be 42 degrees, so we'd have the sine of 42 over 16. And now I can solve for this y piece. It's the y piece that I'm concerned with because I want this angle and the 2 included sides. Because I want to use the formula that says 1/2, we'll say BC sine A. Those formulas to be able to solve for this. Okay, so over here, I cross multiply and I solve it. I get y equals, and in this case it's going to be 16 times, so it'll be 16 times the sine of 109. And then I'm going to take that answer and I'm going to divide it by the sine of 42. And I end up with 22 22.6089 as y. So here's what I'm going to do. Remember, the area is 1/2 the two included sides. So let me show you again. Let me highlight them actually. Let's see if we can pick a color to highlight with. It's this side, this side. Those are the included sides to that angle. So that's what I'm going to do. So over here, it's going to be 1/2, and we're going to say y, which is 22.6089, 16 sine of 29. So that's my area formula. Let's finish that off. And the area is going to end up being, putting all those into my calculator, 87.6881 is the area of that triangle. All right, for the last one here, it has us wanting to use Heron's formula to solve for the area. So let's go ahead and take a look at that. So Heron's formula said the area is going to be the square root of s times s minus a times s minus b times s minus c. And the reason I'm using Heron's formula is because I'm given 3 sides of a triangle. Whenever you're given 3 sides of a triangle, you can easily find the area with this formula. Well, what does S mean? S is the semi-perimeter, which means I need to add up these 3 sides. That's the perimeter. And I need half of it. So adding these up, I will get 5 plus 7 plus 11. That comes out to be 23. Divide that by 2, I'll get 11.5. So the area comes out to be the square root of 11.5 times 11.5 minus 5 times 11.5 minus 7 times 11.5 minus 11. And we work all this out. And I went ahead and put these into my calculator. So the area comes out to be the square root of 168.1875. And taking that square root, I will end up with a final value of 12.9687 square units. I should have probably put square units on this one as well. All right, so here are 6 problems with the law of sines, law of cosines, and then finding the area of a triangle, and then using Heron's formula. Some of these are a bit complicated, especially even though you guys are in honors. This is kind of complicated for geometry. You'll be doing a lot more of this stuff in Algebra 2, but it's good to practice these, so make sure you understand how to do these because one of these may appear on a test. So thanks again for watching. Hit that subscribe button, give it a like, and I'll see you in the next video.